Okay then, so for this last one we use Desmos again. So it says find the solutions for tan of x plus 100 equals 0.3. Okay, so let's go over and head over to Desmos. So let's get rid of these for a second. So here's our regular tan graph, and again we're going to use the regular tan graph to get our solutions. So we'll pick up our calculator, we'll do inverse tan of 0.3 and we'll get our solutions here. Okay, so there's our first one that we'll probably get on the calculator because we always get the 0 to 9, so you get 16.699. Okay, so how does the tan x graph relate to the tan of x plus 100 graph? Okay, now it's not entirely clear from that obviously which way things have gone. Have they gone left or right? So you might remember hopefully the transformations chapter from GCSE or topic, and in particular translation. So how do things move? Okay, so I'm just going to change this to tan of x plus a and pop a slider in here. So let's see what happens then. So they're on top of each other at the moment because you can't really distinguish with the value of 1. Let's make it 0, so they are exactly on top of each other. So as a becomes more positive, what happens? Let's have a look. The blue graph starts moving to the left. Okay, now I won't go into a huge amount of detail because we will do this again at A level, but essentially what's happening is the values that we get for y are happening earlier than they were before. So for instance, if you took tan of 50 and we add on 10 to the 50 degrees we were talking about, that's now going to happen at 40 degrees on our x scale because I'm adding 10 to it. Okay, so before I had to put in tan of 50 and I got value back, but now I only have to put in I only have to put 40 degrees as my angle because here's my angle here, x, but I'm adding 10 to it. So that's going to happen on the graph earlier. Okay, so if we add a number to a function, or within a function I should say, then I'll end up translating it to the left. If I subtract a value, let me pause, hang on. If I subtract a value, then as we can see, it moves to the right because again, let's use that 50 degrees as the example. I'm going to have to put in my x value, i.e. the numbers that I put in here on my x-axis as 60, because then I'm going to take 10 away from it, and really all I'm actually able to do is calculate the tan of 50 from that. Okay, so everything happens later on than it did before. I'm having to put in bigger numbers to get the same values back that I got on the original graph. Okay, and so we can use that idea to quickly get ourselves answers. So now we don't want a anymore, do we? We want 100. So tan of x plus 100 is happening earlier. I'm having to put in much smaller numbers, or indeed negative numbers in some cases, so that when I add on 100, I get the same value that I had previously on the y-axis. Okay, so here let's reintroduce our 0.3. So if you do regular tan x of 0.3, you get 16.699. On tan of x plus 100, that happens, sorry, the wind's blowing my, I slammed my French door, sorry about that. Let's put me off, has already happened 100 values of x earlier. Okay, so here is that same equivalent value. So if I do 16.699 take away 100, I get minus 83.301. Okay, so that's the equivalent value. So let's have a look back at the question then, shall we? So the question was find the answer between 0 and 360. So straight away you can see that while 16.699 is in the range of 0 to 360, if we take away 100 from it, it now isn't anymore. So because we were looking for answers to the tan of x plus 100 graph. So the minus 83.301 is good from a learning point, but we don't actually need it as an answer. So how do we get the next solution? We stick with our regular tan graph. We look for symmetry. We can see that we've added 16.699 to 0 to make this little triangle. Let's scoot along. Right, this point here is 180. So I add on 16.699, I get 196.699. There it is there, there's that point. So that would be my next solution on my regular tan graph. But at that point on my tan of x plus 100 already happened 100x values earlier. Okay, so if I go back, if I take 100 away from that, there we go, I get my 96.699 solution. And all I have to do is keep going on my tan graph such that when I subtract 100, I'm still getting numbers between 0 and 360. Okay, so let's go along. Here's my next one. So I actually have to go outside of my regular range of 360, 376, take away 100, and here's that value that happened 100 places earlier, 276. Okay, as we can see from the blue graph, there's no other points that are there. So feel free to use Desmos to really help you to understand where the values are coming from. Even if you cheat, if you like, by putting in the tan of x, like putting in the function and just reading off the answers, see if you can find the like for like values and what you would have to do to get to them from the original graph. So always draw an original sine, cos or tan graph, and then overlay that with the transformation graph and see how points relate to one another. Okay, so hopefully that's enough for that first one. But just to reiterate, all of these points here, it's great if you can get your head around it now, because we did do it at GCSE, some of us, but it is a topic within A-level itself, but obviously it becomes more advanced quicker.